Hi, welcome to MegaSplat Development Log number 20. We're going to be going over the new custom code features, which should be shipping in the 1.09 version. I'm still waiting for the asset store to approve 1.08. It'll probably be a little while longer before I get around to releasing these. So the feature I'm going to talk about today is a custom code feature. This is sort of an advanced feature if you are familiar with writing shaders and you'd like to extend the MegaSplat shader that you've created with the shader generator to have some custom functions or something like that in it. Some of the integrations, like the Curve World integration, which MegaSplat support, could have been done through this new technique. So that's pretty cool. So the custom user function, basically what you do, I have a rock here that I set up, and it has this shader on it with this MegaSplat material. And it's just a basic MegaSplat material with your normal SAO and diffuse arrays assigned, and it's a two-layer shader. Nothing particularly interesting. But if we turn on custom user function, what will happen is the shader generator will write out two files for us. One is the MegaSplat Custom CGN, and one is this props file. So what these are is a CGN is an include file for shaders, and this is where you're going to write your shader code. And then the props file is where you can add properties that will get compiled into the shader when you compile the shader. So let's start by changing this MegaSplat Custom CGN file here. So when we open this up, my editor is being a little unresponsive. What it has here is essentially some documentation. There's some custom functions that you're going to use depending on which part of the chain you want to insert your code. One is called a MegaSplat layer, and this is, if you're familiar with surface shaders, it's like the surface shaders standard output, but the difference being that it also has a height value for the current pixel. And then we have what I call the splat input layer, and this is a bunch of information essentially about you know, what are the UVs, what are the macro, what is the macro texture UVs, etc. And so with this you can get all the information you need that came from your vertices or from the terrain, and you can use it. So if you want to know your wetness value, here it is. Now you'll notice that a lot of these have if-defs around them. I suggest that you also if-def your code in case somebody turns the wetness feature off. It will break the compilation of your shader if you don't follow the if-defs as well. So let's talk about the functions. There are currently three functions. The first one is a pre-vertex function. So the idea here is that you maybe want to do something in the vertex shader. You could modify the local position of the object of the vertice. You could modify the normal, the tangent, or the UV that's coming in off the vertices or off of the terrain data. So let's just go ahead and do that. Right now we have nothing in here. So what will happen is the shader compiler will strip this function and it'll have no cost. But let's go ahead and add some code. So what we're going to do is we're just going to take the local position's Y value, and let's just just going to create a waveform of the time dot x plus, and let's just use local position dot x. Let's just do this. We'll save it, and we'll go back to our shader here. And now what we see is that we're warping the vertices here. We need time to be a little bit quicker here, so let's just do time times 5. Get a nicer. Oops, that's scaling. Sorry, I want time times 5. Not position times 5. And let's make this times 10. So now what we see is our rock animating in the vertex shader, and you know, we're as an example of how we can modify the vertices. So the next function is the post-tessellation. So what this is you have tessellation on. If you don't have tessellation on, this won't be called. If you have tessellation on, what happens is that the GPU will generate new vertices and displace them. And so this function gets called right before the end of that. And what it does is it passes you the original position of the vertice. It passes you an offset, which is how far it's the vector 3 that says what direction am I going to offset this based on all the displacement mapping that's been calculated. And then it passes you a normal and tangent and a UV. So you can use these to further modify this offset or do something completely different, or maybe you want to use a texture to dampen the displacement in certain areas or to increase it. But the default implementation just says take the offset that we've computed, the MegaSplat offset, and just apply it, add it to the position. And so that's the default implementation, which will just do what MegaSplat would have done if this feature was not on. But again, you can insert custom code here and take it further. And so finally, we basically have a function called MegaSplat function final. And what this is in the pixel shader, when we're done and we've splat mapped everything, computed, any effects, rivers, whatever, we basically get a MegaSplat layer structure and a splat input structure. So the MegaSplat layer structure is very similar, if you're familiar with surface shaders, to the surface shader output, except that it also has a height value for the given pixel that's been computed from all the blending. And then finally, the splat input has all the information from the vertices that you may have ever wanted, or from the terrain's painting information. So for instance, you have, what's the wetness value right here? And you also have stuff like, what's the macro UV, what's the splat UV set to, what's the distance from the camera, what's the view direction. So all things that you might want to do to modify these. And you'll notice that some of these are if-deffed out. So for instance, if wetness is not turned on in your shader, then this variable doesn't exist. So that means if you're going to write code that uses this wetness value to do something, make sure you wrap it in an if-def like this. Otherwise, if somebody turns wetness off on your shader, you'll have a shader that doesn't compile. So let's go ahead and let's add something here. Let's add a texture that we're going to sample and blend with our albedo. Okay. Before we do that, we need to declare that we have a property. So for that, we need to go to this MegaSplat custom property file here. And so if I open that guy up, and I open this, do Sublime Text maybe. What we'll see here is that, again, it's got a little example to let you know what is in this file is for. And so if I actually uncomment this line, and basically all the properties have to start with custom. That's how it knows, hey, this is a property that I should show in the editor. And then whatever your property name is, like my texture. So let's just go ahead and copy this. And now what we have is we have a custom my texture that is set to black by default. We go ahead and save this. And now we can go to that CG Inc file again, which I have in Monitor Develop. We can go ahead and sample that texture. So let's do sample this, and we're going to use the UVs, which let's use the macro UVs. And so if you're unfamiliar about what's in that structure, you can just look up here. There's a chance that this will get out of sync at some point, but I'll do my best to keep it in sync with the actual structures. If you're worried, if you want to know where these structures are, they're in the fragments folder. There's a thing called structs, and it has these structures in it so that you can always reference that. So now that we've sampled our texture using the macro UVs, we can basically blend the albedo. Let's just multiply it by our text value, and we need to do RGB because albedo is a vector 3. So now we've written our code and we've written our properties. Come over to Unity, and what we see is that the shader has not compiled. okay? And this is kind of interesting because basically what's happened here is that we wrote the code before we wrote the property. Additionally, we forgot something very important, which is to declare our custom MyTexture. So that's the real reason that we didn't compile here. So let's just go ahead and add that. Sampler 2D. And if you've, before I save this, I'll show you one of the things with MegaSplat is that when a texture doesn't compile, the editor is basically destroyed. So that is pretty annoying because there's not a real way to get access to the generator at that point. So you really have to fix your shader error right then. So when we add this sampler 2D, we go back. There we go. We're compiled. And now if we select this, our shader editor comes back, our custom shader editor. And what you'll notice here is that there is now this custom properties block, which is not working because we have not declared the property yet. We declared it in our prop structure. We haven't recompiled the shader. So if we actually look at our shader code here, you'll see that it does not have that custom MyTexture in it because we haven't recompiled this. So it just stuck our template in there, which didn't have it uncommented. Now we could uncomment it there and that would work, but the proper way to do this is to recompile the shader. And I should probably add a button here for just recompile, but the way that I usually recompile the shader is I select one of these enumeration options and just set it to the same value, and then MegaSplat will go, hey, maybe something has changed and recompile. So now it's recompiled the shader, and our custom properties show up. And you can see here that this custom MyTexture property that we have is available. And because I had already done this, figuring this out, it had a texture assigned. But now we can assign our texture to this thing. And we can go back into our code, and we can go into my custom CG ink here. I'm going to go ahead and scale up these UVs a bit. Try that. I know the UVs on this rock are tiny, so. And now we can select different textures, and you can see that our custom shader code is running. So that's pretty cool. It means that you can quickly write little functions to extend MegaSplat and write your own custom code. So let's talk about some things with this that are going to be interesting going forward. So I've written these functions right now, and I've put the things that I suspect that people may want to modify in them. But you can imagine that people may want to insert things at any point in MegaSplat, or they may decide that, like, you know what, I really want different options here. And what I want is, like, you know, some extra information that you have, or maybe I want a new function that happens, you know, at some earlier point. Maybe like pre-snow or something like that. So the upgrade path on this is not going to be great, because if I modify MegaSplat to have new functions that are here, then when a shader gets recompiled, it's going to expect that those functions are in your custom CG ink, and that that thing is going to be able to compile. So if you're using this feature, and I consider this to be a pretty advanced feature because you need to be familiar with shaders to use it, if you're using this feature, then expect that when you upgrade MegaSplat to look through the various patch notes that I release, and if I have added any new functions or anything like that, you're going to want to back up these files, and then you're going to want to generate, basically turn off the custom code, and turn it back on to generate the custom functions for you again, and then port your code into it. Otherwise, you may have shaders that are just breaking, and that's no fun. Another way to do this would be to actually go into the fragments and get the, let me just grab one of the fragments. So the templates are actually stored in here. So this is actually the file with all the information about the template, and this is the properties one. So when it generates new templates, it's just copying these. So the other thing that you can do is if I submit a patch and you're using this function, and I've added or changed some of these functions around, is come in here and look at what the new template is. And again, you can copy out these functions, fill them out for your given custom shader, and then make sure everything's fine before you or after you upgrade. The shaders will still work as long as you don't recompile them. As soon as you recompile them, MegaSplat is going to expect that the new code is in your custom CGN. So that's a little caveat with working with this. I don't think it's going to be that big of a problem. I suspect that most people are going to use this to do little custom things like, hey, I need to add like a radar overlay thing to the terrain that draws some funky thing, that I'm going to draw, or change the color of the final output. Now, one thing to note is that this final function happens before lighting. So again, you're getting all the inputs to the lighting equation. You're not getting it's not like final color where you're just modifying the color. You're modifying the actual inputs to the lighting equation. And yeah, so that's basically the feature. It will hopefully make people who want very specific extensions to MegaSplat able to do these without having to modify MegaSplat or worry about, if you upgrade to a new version, that you're going to have to, live without the custom inspectors and things that it provides because you've modified it all or merge all your changes over. So yeah, this is pretty cool. I've still got some more things I want to do to it, and I want to think about what things, what stages of the shader might want to also be exposed. If you have thoughts on that or things you would want to do, even just examples of things, especially if you're somebody who's familiar with writing shaders, please jump on the forums and let me know, and I'll talk to you at that point. So thanks a lot. Bye.